All right, so now we're looking at page 3 from the worksheet posted in document sharing that was kind of like your guided notes, okay? So at the top, I just was wanting to come right out and say again that to try to understand logs, you have to realize they're really just exponents, okay? Log base A of x is the exponent on the base you would need to get x back out, okay? So like if they say log base 2 of 16 and you're trying to understand what that means, think about it like this, okay? To understand what that means, I could switch that to exponential form. So what that means is that 2 raised to whatever this turns out to be should equal 16. So the logarithm really turns out to be the exponent you would need on the base in order to get 16 back out. And see, you don't know what log base 2 of 16 is just looking at it. You're just learning about logs. It's not kind of going to be second nature. But when you look at this, I bet you can look at it and see why what goes in the box has to be 4. So the answer to this would be 4. Okay. So we're going to do just a few of these. I'll show you the rest of them, but this isn't something you really have to do that often. I'm just wanting you to get the hang of what a log is, start getting a sense of it. Okay, so like I want to know what that is, but this is hard to think about. So the base is 3. What's on the other side should be your exponent, and that should give you a 1. Now, when you see it written that way, you ought to be able to look at it and say, oh, I know that's going to be 0. I didn't need my calculator, and that's a good thing because most calculators can't do log base 2 or log base 3. Now, they can do log base 10, but it asked us to try to think about it without a calculator, so we will. Okay, so the base is 10 to some power has to equal 0.1. That's a little trickier than I'm used to. Let me change it into a fraction. 10 to the 0 power equals 1/10 is what that says. So I don't know if you remember, but if you put in a negative exponent, the negative means to do the reciprocal, means to do 1 over your base. So that means that your exponent, this right here, needs to be negative 1. All right, and then these other two really go above and beyond what I'm really expecting of you. If you were trying to do that one, I'm going to do them fast so they're complete, but probably aren't going to ask you about this. 2 to some power equals square root of 2. And then something I'm just now teaching in my Math 100 is that a square root really is the same as a fractional exponent. And so that means this box would need to be a half, wouldn't it? In order for those to be equal. All right, and then on here, I know that e raised to some power is supposed to equal 1 over e to the second. The 1 over makes me remember that it's coming from a negative exponent. And make sure you're thinking that. Like 1 over e to the second is very different from e to the 1/2. These are not equal. So watch your notation. Make sure you're saying what you mean and thinking about it correctly. So that means I know this right here should be negative 2. Okay. All right. Now, some calculators can handle logs of various bases, but most of them cannot, and you are expected to know how to do it without a calculator, how to do logs other than base 10 or base e without a calculator. So sometimes there might come a time where you have to evaluate something like log base 3 of 20. So the way you're going to do it is you're going to do log of the inside, log of 20, and then divide it by the log of the base. This change of base formula just says that if you have something that's a base you're not able to do on your calculator, you can just use the common log and do log of 20 divided by the log of 3. Okay, so over here, log of base a of x is going to be the same as the log of x over the log of your base. That's the log of a. Okay, and this problem, you want to practice typing that in. Make sure that you close that parenthesis before you hit division. Okay, if you do it, correctly, it should turn out to be around 2.73. Okay. All right, let's do a little bit more in this video. Let's go ahead and try to finish this page. Here we're actually getting into the big idea of this unit. And in fact, in algebra in general, the big idea is solving stuff. So we're trying to solve some exponential logarithmic equations, okay? So some of them can be solved using this idea, and it's very effective. All right, logs and exponential functions are really inverses of one another. So some of them work really well to just switch from one form to the other. And so like here, we have the exponential form. And our job is to figure out what x is, to solve for that variable. E is not a variable, even though it's a letter. It's a number that's like 2.72. So what we could do on this is think, okay, well, the base was e, x was the exponent, and I need to do the log base e of 50. These should be written on the same line. The e should be a little lower. Log base e is hooked together, and it has the same meaning as the ln button on your calculator. So the answer to that question should be exact answer. That's the exact answer right there. And then that's approximately 3.912. Okay? All right, and we can also do this in reverse. Like here we have the base. Base of this is 3, so that'll be the base of the exponential, okay? Exponent is 4, so that should go here, and that would equal x plus 1. It's nice sometimes to have the variable on the left, so it's always okay to switch the two sides. You guys know that probably at this level. All right, so that would be x equals 80, okay? All right, and then question number 3, you are going to use the same notion at some point, but you have a little more unwrapping to do. So right here, we were ready to do log of both sides to undo that exponential base e. But here we have to undo adding 5. So that's going to give us 2 times 10 raised to the x power equals 100. Now we're going to undo the multiplying by dividing by 2. That gives us 10 to the x equals 50. And now we're kind of where we can use the log at this point. We can switch to a log form. You have to wait until you get your exponential thing by itself. It just already was by itself there. So now we'll go to log. The base is 10. Exponent should be on the other side. And so log base 10 of 50 should equal your x. So that log base 10 of 50 is your exact answer. And then if you type that into your calculator, let me go back one step. If you type that into your calculator, okay, that's really what log with no number is. And then if you type it in, you should use the log button, the log button, okay, and put in log of 50. And you get about 1.699. Notice it's different than ln of 50. So log base 10 and log base e are not the same exact thing, but it's kind of like how radicals work. They're the same type of thing. Okay, here's the problem on this one. It's a base of 2. So if you go and you try to switch to the log form, you'll have a base of 2. There's your exponent. And 50 would go here. So x would equal log base 2 of 50. But I'd be in trouble because base 2, I can't do. So I have to then know I can switch it to log by doing the log of the top divided by the log of the base. Okay, and then don't forget to close the parenthesis when you evaluate this. If you do this correctly, it should be around 5.644. Okay. And, you can check these. It's like 2 to what power is 50? Well, 2 to the 5th is 32. 2 to the 6th is 64. So I know it had to be a number between those two. So that looks about right. So sometimes I don't actually plug it into my calculator. I just see if it's in the ballpark. All right. So that's the end of page 3. Let me stop this.